So, welcome to a new problem solving session. And this new problem says it is at our screen and it says long toy train, okay, made up of a large number of coupled cars, travels along horizontal rails at a speed v, okay, v, and enters a loop of radius r. So it has got some velocity. Enters a loop of radius r, and loop must have been in vertical plane. Look, there is a problem with the question because this is not the whole problem borrowed from a standard text or something. This is part of a very big problem of classical mechanics, and some part of it, very small part of it, has been borrowed from the book, so many information is missing, but I'm here to cover it up. So first of all, I would like to correct one thing, that initial speed is v0 when the train is moving on horizontal rails, and this loop in which the train enters, the loop of radius r, is in vertical plane. And the next question is, the radius significantly exceeds the size of the car. That means length of the car. Radius of this loop is bigger than the length of a single car, but the length of the train itself is bigger than the length of this loop, that is L is greater than 2 pi r. So at what speed v will the train overcome the obstacle? Obstacle means this loop, so that not a single break, no, this is not single, this is single car. The कोई भी car, मतलब we have to discuss about the car. Car can break off the rails, any one of the cars, so that not a single car breaks off the rail during the motion. Okay, so this is the problem. And where can we start? So I'm focusing, I cannot be too sure, so I'm focusing on using principle of physics. And first principle I would like to use is the principle of conservation of mechanical energy. So when the loop is completely occupied by the train, I want to know the speed of the train at that moment. When the loop is completely occupied by the train, still some part of the train is on the horizontal rail. That means what I'm thinking about, that let me have a loop and a horizontal rail. And right now what I'm thinking, that the train has occupied the entire loop, still some part of it, because its length is greater than the length of the loop, circumference of the loop itself, so some part of it must lie on the horizontal rails, but the train is at least occupying the total loop. So what can be its speed at this moment? The speed of the train initially, if its initial speed is equal to v0 and mass of the train is capital M, what should be the velocity of v at the moment when the train occupies the loop? So it can be found out using mechanical energy conservation, and mechanical energy conservation is used because friction is not working here. Friction might act between wheels of the train and the loop surface, but it will not work. That means it is rolling. And if you don't know what is called a rolling, kindly consult somebody or a book. I don't have the time to explain it right now, but I will explain it one day, not right now. Sorry, if you are feeling low, so but I have another job at hand, so I'm going to do it. So I'm going to write down the conservation of mechanical energy. And what should I write? I should write the initial kinetic energy, half mv naught square is expanded into half mv square, that is the speed, or there is a kinetic energy of the train right now, but plus potential energy has been gained by a part of the train, though not by the whole train. So mass of the train that has occupied this loop should be m 2 pi r divided by l, and mg. And what is the height? Its center of mass will be at the center of the loop, so the part of the train that occupied this dead loop has gone up a length r, that is the radius of the loop. r radius गया है भाई, इतना ही गया है. सो ये होगा इसका एक्सप्रेशन, मैकेनिकल एनर्जी का एक्सप्रेशन. इसको यूज़ क्या कैसे कर सकते हैं? तो इसको यूज़ कर सकते हैं हम लोग, इससे हम लोग वी नॉट का वैल्यू निकाल सकते हैं. सो आई शुड बेटर नॉट राइट इट इक्वेशन 1. I should write something else as equation. V naught square equals V square plus 4 pi r upon L into gr. Oh, it looks fine. This is the equation number 1. ये हमारा पहला equation है. But I have another problem. Any one of the cars of this train should not derail. So cars, where can a car derail? It should be at the highest point of the dead loop, because so minimum velocity was required, and under the condition of minimum velocity, the normal reaction at the top is equal to 0, just greater than 0. T tends to 0, just greater than 0, so that numerically it is taken equal to 0. That means in the limiting case it corresponds to a 0 normal reaction force at the top. वहीं पर डिरेल हो सकता है टॉप पर, और वहाँ पर नॉर्मल फोर्स का वैल्यू 0 होना चाहिए फॉर द मिनिमम स्पीड. ओके. और कार को हाईएस्ट पॉइंट पर, जो भी कार होगी, चलो जो भी कार होगी हाईएस्ट पॉइंट पर, जो भी कार होगी हाईएस्ट पॉइंट पर, नो 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 दिस ओनली. ओके ओके ओके. हाईएस्ट पॉइंट पर जो भी कार होगी, उस कार का कुछ होगा. मान लो ये कार है, कार रेडियस के मुकाबले में बहुत छोटा है. लुक, आई एम गोइंग टू टेक दिस एंगल अल्फा, एंड अल्फा इज़ वेरी स्मॉल. तो यहाँ टॉप पर और कौन कौन से फोर्सेस लग रहे होंगे? नॉर्मल तो 0 हो गया होगा, तो एक तो फोर्स ऑफ ग्रेविटी लग रहा होगा. सो कार का मास मैंने स्मॉल m मान लिया. एक कार का मास, टोटल ट्रेन का मास कैपिटल M माना था. सो मास ऑफ वन कार इज स्मॉल m, एंड तो फोर्स ऑफ ग्रेविटी लग रहा होगा, एंड द टेंशन फोर्सेस from the rest of the train, and that will be in this direction and this direction as well. और दोनों डायरेक्शन से टेंशन को मुझे डिफरेंट लेना चाहिए या सेम लेना चाहिए? सेम ही ले लो, क्योंकि दोनों तरफ नंबर ऑफ ट्रेन्स तो सेम ही है, नंबर ऑफ कार्स तो सेम ही है. वैसे भी डिफरेंस होगा भी तो काफ़ी कम का डिफरेंस होगा. व्हाट शुड आई टेक द टेंशन एट द टॉप? तो मैंने दोनों तरफ से सेम ले लिया. टॉप पर है तब, यस आई कैन टेक इट, so that this angle is alpha by 2, so this angle is alpha by 2, and this angle is also alpha by 2, so that t cos alpha by 2 gets cancelled out, and here is 2t sin alpha by 2. नीचे की ओर दो फोर्सेस लग रहे हैं, ग्रेविटी एंड दिस, एंड ये दोनों नीचे की ओर लग रहे हैं. तो ये दोनों क्या प्रोवाइड कर रहे होंगे? क्या प्रोवाइड कर रहे होंगे? या ऑफ कोर्स सेंट्रीपिटल एक्सेलरेशन, नथिंग एल्स. सो दैट ऊपर में जो इसका सर्कुलर मोशन का इक्वेशन है, एट द टॉप आई कैन राइट that 2t sin alpha by 2. Alpha is quite small, so I will write simply as 2t alpha by 2 plus mg should be mv square by r. पूरे ट्रेन की तो एक ही स्पीड होगी, v है, v है. अभी एक कार टॉप पर पहुंची है जो कि डेंजर में है, उसी के डिरेल होने का खतरा है. सो दैट व्हाट विल बी द मास m. m इज इक्वल टू m, उसका लेंथ कितना ले लें. लेंथ इज, मान लो कि L ले लेते हैं. ट्रेन का लेंथ मैंने L मान लिया. ml by L. What can be in terms of alpha? What can I write it? L equals alpha multiplied by R. नहीं, L equals alpha R. Okay. That means small equals m alpha R by L. Okay. Right. Okay, I have written all those things. And हमारे पास फाइनल इक्वेशन क्या आ गया. T लेफ्ट हैंड साइड में T अल्फा m में भी अल्फा है, दोनों तरफ m है. अल्फा विल गेट कैंसल्ड आउट. सो आई गेट द इक्वेशन समथिंग लाइक T प्लस R बाई L mg equals mv square by L. This is the equation I got. This is equation number 2. But it now remains to find the tension force T. How can I find this tension force T? This is a big headache. I know this is a big headache. How can I find it? तो कार तो वहाँ पहुँची है. टेंशन को कैसे कैलकुलेट किया जा सकता है. टू कैलकुलेट दिस टेंशन, आई नाउ कंसिडर दैट let the train be displaced by a small length delta x. The total train is displaced by a small length delta x. And the speed of the train does not change. How? Why? Let us assume the speed of the train does not change. Then what happens? This is an old technique. सिर्फ टेंशन को वर्क डन निकालना मुझे, फोर्स ऑफ ग्रेविटी, बाकी चीज़ों का नहीं कैलकुलेट करना है. टेंशन को तो ट्रेन मान लो कि किसी ने ट्रेन को काफ़ी वेरी स्मॉल लेंथ किसी ने पकड़ा हुआ है और कोई बाहुबली आ गया. somebody is standing there and it pulls a very small length delta x. जस्ट उसको हिला देता है अपनी जगह से फॉर ए पॉइंट डिस्प्लेसमेंट dx. दिस इज लाइक कि इस पूरे केस में, इतने बड़े केस में, दिस इज लाइक कि आपने डेल्टा एक्स लेंथ के किसी बॉडी को, डेल्टा एक्स लेंथ का मास क्या होगा, मास भी मैं फाइंड कर लूँगा. ये डेल्टा एक्स लेंथ के किसी पॉइंट को यहाँ से यहाँ खींच के ला दिया है. ये बॉडीज में दिस इज अ गुड आइडिया कि forget you want to use work energy theorem in a big case, in a long rope or long rod or something like that, and you want to find the work done, not the work done by all the forces, but work done by tension force or something like that. Then you should use the idea the train speed has not changed and we displaced it by a point, distance dx. Then work done by the tension, it will be simply t dx, and it means you have just pulled a point of length dx from this point to the top, and this is the change in potential energy of this is only some kinetic energy has not changed, so this is only the change in potential energy of the object of length dx, object of mass dx. So I can write here T dx is simply m by L upon dx g into 2r. 2r is the height. So I can get here T dx is equal to this, so I can get here T equal to 2g r multiplied by m by L. I got the value of T, and this value of T can be put into this equation, and we can get the value of v square. Then what is the value of v square? We got 3gr. So we can get by putting this value into this equation, we get v square equals 3gr. And so the minimum velocity required for the train to cross this obstacle is simply equal to under root gr 3 plus 4 pi r upon L. The whole value we calculated earlier. This is the value of velocity. We needed to put this value. Minimum v naught. We got the value of v square as 3gr, and we got the value minimum velocity v naught equals this, and v naught minimum, I should write like v naught minimum, and this is the problem. That is one of the difficult problems, but I have got it correct. Thank you very much for watching.